All right, everyone. I think it is time to get underway. Thanks for joining us this morning. You are on Dynamic CPD, Professional Development and Networking for Discerning Designers. And today we have another one of our webinars. This time we're introducing a new product. Going to be an exciting one. This is a product called SlabTank, and it's being presented by the team at QPod. Our main presenter today will be Peter Crawshaw, backed up by Sam Talbot. Now, just for those of you who have been on before, or maybe haven't, you can answer questions during the webinar in the Q&A box, and we'll endeavour to answer those as we can. And the webinar will be recorded and available afterwards as well. So today's topic is a really interesting one for me. It's relevant to civil, structural, and geotech engineers, really, architects, builders. It covers a lot. And we're really looking forward to it. Just before we start, as usual, we do have to just point out that this information is general in nature and is correct to the best of our knowledge. However, you must engage the services of a chartered professional engineer or other suitable professional in the jurisdiction you practice in for advice before using this information in any specific project. And all information is supplied subject to the terms and conditions of Earth Engineering Limited, which is available on our website. So with that, I will hand over to Peter, and I'll ask Peter to just do a quick introduction to himself and the company, a little bit of the history maybe for those who are not familiar with it. And then, yeah, tell us what you got, Peter.
Thank you very much, Michael. Certainly privileged to jump on this morning and share this system SlabTank with you all. Thank you for joining, everyone, and good morning. Yeah, really looking forward to sharing this with you. A little bit about ourselves I'll touch on. I'll go through what we're going to have a look at today through the menu with you, and just familiarising yourselves with this platform. We had a really exciting session last month, so this follows that one. And then what we do open up for all of you to engage with is to fire your questions in the chat as we go along, our chat box at the bottom, and we'll seek to interpret those and answer them as we go. So let's jump on the next slide. So looking at what we'll cover today, we'll have a little look at who we are, ourselves, who I am, and what we do at SlabTank. Water attenuation, why it matters. Stormwater matters, what SlabTank delivers, slabs, driveways and piled foundations, just how it works, the versatility of it, installation overview, maintenance, rainwater harvesting, and implementation. So a little bit about ourselves. So I'm Peter Crawshaw, General Manager here at QPod and Castle, and we've been innovating in the plastics and construction industry for 40 years now. My father innovating in plastic moulding. So one of the little image on the right there is one of our first plastic moulding machines coming into the factory 40 years ago. So you can see it's a little grainy, and so continue to grow certain amounts since then. So you can see some of the brands down the bottom left there that we're associated with and have developed. So SlabTank is really coming off the back of a lot of that innovation. A little overview of where it's come from. I'm sharing the QPod video here. This is the QPod foundation system, which if you're on the webinar last month, you would be familiar with this one. But this is really where the backbone of where SlabTanks come from. A lot of the structural integrity and design has come out of what we've developed with this foundation system. So we've worked with the system with recycled plastics and taking this system New Zealand wide and now to Australia. And then off the back of that, using that structural design, the integrity of the leg in this product is what we've modelled into our water storage tank. So we had a lot of requests from clients saying, hey, can you store water in the system? And for a long time, obviously, we haven't been able to until today when we launched SlabTank. So So really excited to share this with you today. So why attenuation matters, I think we're quite growing familiar with this now. So urban growth, New Zealand, we're a fairly young country, but we are growing and we've got more hard surfaces, more runoff and stormwater issues. Rising flood risks, obviously that is an increasing risk that is upon us, and old infrastructure as well. So our stormwater systems are getting old. Were built for the climate 50 years ago, not for the next 50. So there's things we've got to do to manage that. So pictures on the right here kind of tell you the story. Opportunities to store water. Obviously, a slimline tank is a great opportunity. However, you get a tight site and narrow boundaries. You know, you struggle to get a wheelbarrow down the side of the house with a tank like that. So certainly, clients are looking for other options. And when you've got a lack of space, underground is an awesome opportunity to put some of your stormwater attenuation. So we sought to deliver a tank from the slab here, and this is what we come up with. So this is the SlabTank. It is a tough Kiwi-made product built from MDPE, so it's a plastic rotational moulded product, much like your rainwater tanks. And what you can see on the right there is a representation of it in the foundation. You've got the tanks, you've got the connections out the left there, and you've got the distribution chamber, which is really your central hub of catching your water and distributing it. So we're after a low profile tank with large volume. So that's a 950 litre tank. It's 3.3 metres long, 1.1 metre wide. So it is a large tank. It does mean obviously less tanks involved to generate the litrages you're trying to catch. No interconnections. So this was a real key feature of our development process. So taking out those connections within the slab and adding, just having those connections on the outside. This means obviously there's a lot of, removes a lot of anxiety around those connections and the possibility of leaking. So that it's one moulded tank with a moulded spigot right to the outside, and then you connect it up on the outside like it's pictured there, in sequence to your distribution chamber. Really important feature of the SlabTank. And as mentioned, coming off the back of QPod, it's designed for strength. So as you can see here pointed up, got all the green legs of concrete going through the pod. So this is a unique patented part of the SlabTank design. This means that you can put these in sequence in a floor foundation, under a garage, under a drive, and it's going to take the load bearing requested by vehicles parked on it. So suitable for in houses and garages and driveways, like I mentioned. The dimensions, so we've got two sizes that we've taken to market. That's the 300 high and the 220 high, each delivering respectively 680 litres and 950 litres. The top-down dimensions are equal for them both, 3.3 by 1.1 wide, basically. So they fit in sequence, much the same dimension structure as your pod floors.
Peter, I might just jump in here. We've just got a couple of questions which I think you might be about to answer, but
yeah, fire on.
We can just get them in. So just one question: how does the tank tie in with foundation design?
Yeah, great question. So just looking at, we will cover off on that on these next slides, but essentially it is modelled around the QPod system. So it's the same dimension, same leg structure. So that it just really goes in right beside the QPod. So I will show it on the next slide. So it's probably better I just dive into that. Was there any other questions?
Yeah, just one other question as well here. This will probably get covered, but what does this system create? Any issues with thermal insulation requirements beneath the slab?
Absolutely. Well, I'll cover the thermal question now because I don't have a particular slide on that one. We are looking at having that modelled up by the same modelling company that's done a lot of the thermal modelling for New Zealand foundations. And the comment so far is it will be modelled as empty, which will be pretty similar result to QPod in terms of a thermal R value calculation. Until then, all our installations or going to consent at the moment are in driveways and in garages, so can be thermally separated. But yeah, we will be seeking to get that R value evaluated very shortly.
Perfect. Thanks, Peter.
Cool. So we'll dive on to perfect in a slab for TC1. So this kind of demonstrates here how it works in the slabs. It kind of answers to that question. We can see the typical perimeter detail there, the tanks, and in this case, QPods. I just want to probably emphasize here, this isn't tied in specifically with QPod. Obviously, we are one company. We're launching this off the back of QPod. But hey, if you've got a raft floor or some other type of foundation, SlabTank is an independent system and can be put in with anything at your choice. So here we see a TC1 type application. It runs completely in synchronized with the QPods. This does mean you don't need ribs in the QPod code mark system. And just on code mark as well, we'll be seeking to get this tank into our existing code mark, so it's available for those good ground conditions. For TC2, this is probably a common question. What are we going to do with expansive grounds or liquefaction grounds, or TC2? So with that poor ground bearing and our lack of ribs amongst these tanks, so you can see the top right there, I've demonstrated 3 tanks in sequence, and then you can see the green thickenings and the ribs extending out as an example. So that's really showing how it would tie in with a typical TC2 raft floor, where you've got your ribs at 1200 centres. Those ribs would be regenerated in a 300 rib at 3.3 span, if you follow that. So recreates your shear further out. And that's kind of how it kind of keeps it real simple in terms of keeping these tanks together and with installation, and then fitting them into garage spaces in the slab.
Perfect. Thanks, Peter. Hey, we've got a few more questions. We got one on a driveway, so we might
just
ask
on driveways now, but
after the slide. But there's just a couple of other questions as well. What does having large volumes of water passing in and out of the subfloor do to H1 value, as the water temperature will affect the slab like a giant radiator? If there is cold water coming in and out constantly during a heavy rain period, the cooling effect would be considerable.
Yeah, great question, and that is valid. To be honest, we haven't modelled that. It's a really hard one to model, but we can see what it's going to do in theory. We're going to have a lot of cold water going in there, potentially drawing that heat source out of your floor. Yes, it would be a factor, and probably something you would really consider if you're boiling down the thermal parameters of what's going on in there. If you're really trying to get that green star or the high R value rating, you would possibly consider those. And I think I don't know if Jason Quinn's on the call today, but he'd be a great one to answer that, which many in the industry would be familiar with. He's a great one on that one. He's done a lot of the modelling in New Zealand, but sorry, I don't have an exact answer for that, but we can understand the theory there.
Nice. Might just shoot into a few more questions too, if that's okay, just as they sort of come through.
Sure.
So Alan asks, does this slab design require any cantilever ribs?
Great, and that's kind of what we were demonstrating earlier there with the example in a poor ground bearing condition. So these ribs here, or these restructure of ribs, thickenings, are essentially your cantilever creation. So that would essentially generate your shear strength and cantilever in those ribs. I don't know if that clearly answers it, but it's probably better answered in a long text than an email. So happy to try and address that one afterwards if that doesn't cover it.
Perfect. And just, is there any settlement issue if there is a peat layer underneath the Q pod or slab tank, I suppose, more specifically?
Yeah, certainly. And with any slab and geotech report, if you've got peat layers or any unstable layers of sorts, that's where a geotech report will give us answers as to that, and we will need to do ground improvements to meet suitable ground levels. Essentially, you're improving the ground as you would for a typical raft slab.
Perfect. We might leave the questions there for now. We've got a few more, but just also mindful of people's times, and maybe we'll shoot into a few more in a few
Some of them might answer as we go. So
yeah,
absolutely. Then Sam, and if there's anything we don't answer as we go, just fire them in there, or if they're relevant to the screen we're on.
Yeah, the next one's just around. The next one is specifically around trafficable areas. So if we can just make sure that we cover this one, this question in there around sort of cover required for trafficable areas and backfill in terms of bringing concrete up to ground levels within the driveways, then we're good.
Yeah. So this is kind of what we're covering here with driveways, trafficable areas. Again, you're preparing that ground to 200 kPa, putting that sand blinding in, putting your tank in, and then covering that with 100 mil of concrete. Obviously, as I demonstrated earlier, you've got all those bearing leads going down through the pod. So your driveway and the trafficable area is basically bearing down on those load points. Those load points are bearing down on your improved ground. And those load points are at 550 centres, and it's a 160 millimetre diameter lead going down, which that is tested to a 6-ton jack point loading without failure. So between the two load points. So you can see it's perfectly suitable for driveways, for garages in that respect. In terms of, say, lawns or gardens or metalled areas, we haven't got particular guidance on that yet, purely because those areas wouldn't be typically trafficable over top of these without some good ground improvement above it and probably some very deep embedment. We're really focusing these tanks for driveways and house slabs, and really leaving those deep ground tanks to a different area of the market. Not to say they couldn't be used, that's probably just not the ideal purpose. Driveways, and obviously under decks. So under decks or pile footings, again, you can slide these tanks. Being nice and low profile, they can slide in there in between the pile footings. So great option there as well. Jump there. So I just wanted to go through the distribution chamber, because that chamber on the left is an integral part of the system. That is a product we manufacture along with the SlabTank as well. So your stormwater comes into that chamber, it distributes to the tanks. The tanks then fill up. They've obviously got a breather at the top, which is indicated there by the dashed line. That obviously allows the tank to fill, which that returns to the chamber. That chamber then is your distribution or draw point. So you've got the orifice set there for the outlet for detention purposes. And then you've got the overflow there. If things fill up, it goes over that 100 mil overflow and down out to the outlet again. If it is retention or a percentage of retention, obviously you set that orifice at the height you require, or at top height, you just have an overflow if it's 100% retention. And then that chamber serves as your draw point for rainwater harvesting, which we'll cover off on a later screen as well. All right, now just having a look at next slide. So installation, easy to install. So this little Lego dude here just tells us how easy it is to install. So prepare the ground, obviously as per your geotech report, removing organic material, loose soil, and what's outlined in your report, and compacting to 200 kPa ultimate bearing, or obviously as per design or as per the geotech report again. Create the tank bed, so adding that 25 mils of sand blinding over the compacted subgrade, create a smooth tank base, and then installing and connecting. So putting those tanks in, obviously they're large volume, so they are a large tank, and will take 3 or 4 persons to lift it in after it's been hired to site. They simply put them in, and a registered plumber can connect them up. It doesn't require a specialist SlabTank installer, just a registered plumber is certified to do this work. So it does open up on site for the contracted plumber to complete this works, making it easy for developers as well. So connecting them up, and then obviously backfilling and pouring the concrete. So pouring it along with all the pods, all in one pour. Your steel and reinforcing is all integrated with the pods. So thanks, Ethan, our little Lego man, for demonstrating that easy process. Maintenance, that's really revolves around this central distribution chamber again. So here again, here's Ethan peering in there. He's a bit concerned about what's in there. He's probably checking the any silt or leaf gathering in the chamber. There won't be a lot. He's probably surprised because the leaf guards or whatever's been put in place on the spouting has done a good job to divert all that. But hey, you might get a little bit in there, and that's what goes to the chamber before to the tanks. So in the chamber, it catches it, then it goes off to the tanks, and obviously you're maintaining that chamber at a regular interval depending on your situation and installation. The orifice, obviously you're cleaning that. So you've got an orifice with a hole in it that's allowing the detention or distribution to the curb. Now that'll just be a removable cap with a mesh inside, which you can also remove and blast that out if it's got something gathered up in it. But it takes a bit of blocking up. But that's also serves as a rodent and mosquito screen as well, stopping it getting back into your water if you're seeking to use it for potable application later on. So it's probably something else we can discuss here. So the SlabTank rain harvester auto, this is an add-on system. So if you are wanting some retention or rain harvesting, you can then hook this up to your distribution chamber. You have a pump, and that might be located directly above it, might be in a shed beside it or under a pump cover. That operates along in conjunction with the float switch, which obviously turns the pump off if your water level runs low in there. So should that water level run low, you run out of retention, your mains takes over. That's where the EquiSaver valve comes into play, and your mains feed through when your pump doesn't operate. So the three kind of work in a conjunction and really make it a plug-and-play system, really safe and reliable, obviously giving you water cost savings where you're paying for water at the moment, and really just putting it all onto autopilot so you don't have to worry about it. We've really designed this to be minimum maintenance. Obviously, you've got to maintain these things for them to work for you, but we're trying to make it easy. We're trying to make it so easy, a homeowner can do this, and they can scan the QR code, have a look on our site, work out how to maintain it themselves. Cool. Any more questions in on that, Sam?
No, I think we've got a few questions stacked in here, but I think we can answer them at the end.
Nice. Yeah, we're kind of coming to the end, so that's awesome. So pop any other questions you've got in there. Implementation tips. We've got a QR code there, so go ahead and scan that. That'll take you through to our web page, which has got standard detailing. It's got easy install guides and our launch dates, obviously September. So we're back ordering for this now. So go ahead and scan it. You've got all the resources there. And like I mentioned, get those questions in. We'll be glad to cover them off now. So I'll leave that QR code up there for those that still want to scan it. And Sam, you kind of fire those questions out. We'll see what we can do to answer them now, shall we?
Sure, yeah, absolutely, yeah, and yeah, as Peter said, please keep adding them into the Q&A box. We're here to help. So, yeah, first question here: any issues identified or testing done in frost-prone areas?
Great question. In terms of frost prone, there is the vent to consider, the height of that, but no particular testing done on that. Like I say, it is, I guess, early launching of this product, so I haven't got a direct answer on that at the moment. So we'll seek to answer that in an email following this if we can.
Perfect. Yeah, another great question here as well. Could placing them in the garage mitigate thermal loss?
Absolutely, yep. So place them in the garage. Obviously, the garage can be isolated out of the thermal calculation. So yes, garage is a great option for it, and that's where we're getting specification at the moment in garages and driveways. But hey, in saying that, is they haven't always got the luxury of having that garage, say in the multi-unit developments. So like I said earlier, we will be getting thermal modelling done to reflect what it contributes in the house area.
Excellent. Another question as well. When replicating your TC2 tanks and needing to incorporate the stiffening ribs, does the external water connections then mean no water tanks internally of the ribs?
Correct. So no water connections going through ribs internally. It'll just be those external spigots going through the perimeter, in which you would do a deepened footing to bring your steel underneath them. So correct. So that is one of the key features of the SlabTank. We really set about to have no internal connections, no risk of flexible joints in the slab, giving or moving in a seismic event. It is a one sealed unit right to the outside, which we know in the plastic that it's used. It's a very flexible plastic, obviously much more flexible than concrete is. So your concrete would have to have quite a seismic event through the slab to create a problem, in which case your slab would be in the problem itself.
Perfect. Dan also asks, how do you incorporate piles for a pile foundation into the pods?
Excellent. So you'd really be putting the piles at centres, obviously relating to the SlabTank dimensions. So obviously those dimensions are 3.3 by 1.1. So you'd be putting those piles outside of those dimensions. So if you're planning a deck or a pile, small dwelling, just think about those pile centres in relation to the tank.
Cool. Excellent. Great question here. So we typically detain water at 40 litres per square metre of roof area. Therefore, we might need 10,000 litres of detention for a house. That's 11 big tanks. Has anyone done this much in one slab?
Great question. It is a lot of tanks, and the answer is yes. We are doing one to that size. We are doing some to that size, and it has been in driveway to date, and what we've seen specified. But there's no reason why that couldn't be in slab as well. 10 tanks, 11 tanks. You can keep going as many as you wanted, really.
Perfect. Okay. And a question I think was sort of covered off, but just any capacity to include filters for leaf litter, etc., in the system, presumably before flows reach the tanks. So I think we covered that off, I think, before that question popped up. So
yeah, okay. Yeah, we'll just jump back to that distribution chamber diagram. So really you've got your, doesn't show there that the leaf guards, essentially you'd have leaf guards in your spouting, which would divert that before getting to the chamber. The chamber would then be your secondary point of litter collection, of which would just be fines, which would collect in there.
excellent. Cool. Thank you. What are the key design considerations for tank buoyancy in areas with shallow groundwater?
Yeah, tank buoyancy, essentially, these are designed to be quite shallow set, if that's the right way to put it. I mean, in a foundation, typically you're above groundwater levels. I guess you could picture the same scenario with a raft slab having air pockets in there. If your water's getting up inside those air pockets, there's possibly another underlying problem, really. So, in the context and the scope of which these are applied, I don't think buoyancy is a problem there. As I mentioned, putting these in drives in slabs, putting concrete over top of them, which is bearing down through them. Yeah, I'd really have a question about the geotech situation. Obviously, I don't think we'd be doing a slab. We had that sort of groundwater issue at that level. Sorry, hopefully that answers that question a little bit, Sam.
Perfect. Yeah, thank you. Another question. Are many councils on board with this?
Councils, it's actually really new to councils, so I couldn't say councils being on board with this. Obviously, that's what would be focused on educating councils, like getting all your good people on here today. So we'll be seeking to do the same with councils as well.
Perfect.
There are some getting familiar with it now, but yeah, I can't say they're all, on board with it.
Cool. And can we provide a PS1 for the tank install?
Yes, so we're seeking to get it code marked within, obviously within good ground conditions, so that it can be installed with the QPod system within those parameters. So that code mark will cover essentially like a PS1 would. In terms of other situations where it requires SED design, essentially that would have a PS1 for the design of the foundation and the tank, which is actually a great question. It is a service we offer and are doing at the moment. So we'll actually design the full foundation design, and the attenuation requirement in it. So there's a service we offer with a PS1 to go with it, yes.
Nice. Great. Thanks, Peter. And
just a bit more on that, Sam.
Yeah.
For any engineers seeking to use the system, absolutely. So they'll be putting it in the system that they're designing and issuing a PS1 with the structure of finished foundation design.
Perfect. Great. Thanks, Peter. And have we had any discussions with Wellington Water about this being an approved solution for stormwater neutrality?
No, we haven't. I have got their contacts and have been led to reach out to them. So it is absolutely on our task list.
Nice. Perfect. Thanks, Peter. Is there a maximum cover under driveways, for example, for steep sites?
Maximum cover, so it might be topping cover. I mean, that's 100 millimeters of concrete is our guidance there. For steep sites kind of raises another challenge. If you've got steep sites, you might be staggering the tanks down, which I'm not quite sure how well that would work, to be honest. You'd get a lot of head in the top tank. So a little bit of creative thinking there. It probably would need to be a specific engineered design, which we need to have a look at.
Well, if I could just jump in there, Peter, I think the question might be around maximum loadings on the tank for long-term creep rather than minimum loadings. So if you get a steep site, you can get some quite significant soil surcharge loads on that. But I think, the interesting thing is there is those holes through them, which are load bearing, and it would have, but as you say, that would have to be engineered design. The tanks themselves are not designed to be buried at great depth, are they? Is that correct?
They're not designed to be buried at great depth. No, they are very shallow, and they're more designed for this application. Shallow application in a slab or in a drive. Yeah. Thank you. Cheers,
Great.
Mike.
Yeah, thanks, Michael. If we were to place them under a deck, could 2 tanks be stacked to increase volume if desired?
Yeah, that is actually a feature we've implemented in it. I don't know if you noticed on the top of them, they've got a shape in there, which is when it's in a foundation, that little chair creates a spacer for your mesh. And then when you put this in a deck, that doubles as a stacking or nesting point in which the tanks nest directly on top of each other. So the same shape as in the bottom of it, they nest together, you can stack them up, and you obviously get some more literage vertically.
Nice. Is the plastic HDPE or HDPP or other, and what is its resistance to hydrocarbon spills?
It is MDPE. Hydrocarbon spills. Sorry, I probably couldn't answer on that one right now, actually.
Could I jump in on that one, Peter?
For sure.
Yeah. So I've done a bit of work on that with hydrocarbons and HDPE. This is an MDPE, which is similar except for the density. There is no adverse effects on the polymer from hydrocarbons. And in fact, one way we can demonstrate that is that the HDPE liners are commonly used as primary containment in petrol storage areas. So that's a lot more intense. But yeah, with there's been a lot of testing on that, especially in relation to geogrids, and the polyethylenes are not they are inert to hydrocarbons.
Yeah, perfect. Cheers for that, Michael.
Yeah, thanks, Michael. Another question here. Is this directly applicable to standard designs in Australia? Are there internal ribs like a typical pod slab, or do the 160 concrete piers replace the internal ribs?
That's a great question. And yes, those concrete piers do replace the need for ribs. So they give the slab the bearing down instead of ribs. Obviously, where you've got reactive clays like you do in Australia, like we have in Northland of New Zealand, that is where the rib does generate shear strength as well, and that's where I demonstrated also the ability to run that in what we call TC2 soils. So essentially you'd run 3 in series and then stop and have recreate those ribs, and then you could run 3 in series again, as demonstrated in this picture here. And then in between that span, you'd have the legs doing their work for bearing strength.
Excellent. Just another question as well. Could the system be adapted to provide flood volume storage?
Certainly. I mean, these are designed to carry water. Just the caution on where you're picking up that flood water from. If you're picking it up off the drive, you could be involving a fair bit of silt in that catchment. So hence the distribution chamber would catch a lot of that. But yeah, you would tend to run the risk of blocking them up more doing so.
Okay, perfect. This one's more of a comment than a question, which is great. Thank you. So Waitomo would welcome the use of this type of solution, particularly in areas of significant interest to our tourism industry. I would imagine the same would apply to any area with restrictive district plans.
Yeah, fantastic. Yeah, that's why we're launching SlabTank. It's generating a lot of interest around the country. So thanks for your support. Obviously, in your tight areas where you don't want the visual disturbance of an above ground tank, this is where a great option for those applications.
Absolutely. Another question here from Sven. He's asking, where are these manufactured and can they be delivered to both islands?
Yes, they are manufactured in Manawatu. As we scale up, we'll be manufacturing in areas around New Zealand, potentially be setting up in the South Island as well in time. But yes, we'll be distributing these nationwide from our North Island manufacturing facility.
Great. Thanks, Peter. Does the shallow depth capacity preclude positioning these in a vertical configuration behind a lower boundary retaining wall?
They aren't designed to be installed vertically. Not to say we can't test that. So, great question.
It's a good one.
I guess you could stack them up vertically, like on top of each other behind a retaining wall. Again, it's not, we were focused here, but absolutely open to these creative suggestions. We're going to open up markets that we never knew were there.
A good one. Okay. How will this system be sold in New Zealand, and do you have interest in overseas distribution?
Yeah, so this system will be sold in New Zealand direct to developers and then through trade stores, obviously. We obviously do a lot of marketing and sales effort ourselves around New Zealand, and the availability in Australia. Did I get that, Sam? Was there an offshore?
Yeah, just around sort of overseas distribution. Are we going to sort of sell them anywhere outside of New Zealand?
Yeah, we're actually looking at exporting a certain amount at the moment to some of the islands. And then in time, we will take it to Australia like we have with the QPod. So I think it's a great opportunity right there. And yeah, for other offshore islands, offshore countries, absolutely, I'm open to look at those opportunities.
Great. Perfect.
More than likely, set up manufacture at the place of interest, just due to the sheer size of these products. So be looking at the opportunity and obviously capacity to take it to market in a new country.
Great. And one last question for the time being, but please feel free, folks, to add any more. We're happy to stick around. Are recycled plastics being used in these tanks at all?
Absolutely, they can be. The focus at the moment is to use virgin plastics purely for future use of these. People are putting these in for detention, and then a lot of people are putting these in for the future thought of, I might be able to reuse this water in time. And so if they seek to turn that into potable water through a filtration system, we'd like to think there's a tank under their slab that is purpose-built for that, so it's ready to go. We could absolutely make them on request out of recycled plastics, completely doable, but it limits its use, I guess, in the market.
Perfect. And yeah, more of a comment, I suppose. Designers will need to watch placement of bottom plate fixings. Some tradies are better than others at drilling bolts to floors.
100%. Yeah, and that is a challenge. You've got tanks under your concrete floor. You've got some brace walls. You've got some hold down bolts. And typically they're always going to be on thickenings that are allocated in the slab. But I have heard, obviously, when you're going to tilt up or brace a wall temporarily and put a bolt through the floor, you go sticking that through too deep and into a tank, you'd be very disappointed. The measure there is to be aware with the builders to mark out those areas where the tanks are and really take those precautions.
Fantastic. Well, that's it in terms of questions we've got this side, Peter. So I'll leave it to you.
It's really exciting to be part of contributing to a sustainable urban design in the future. So appreciate all your support jumping on today.
Perfect. Just one last question. Sorry.
Yeah, for sure.
Understand QPod have end caps attached. How would you deal with leakages since there will be many joined parts?
Great. So QPods is very much a modular system. Sometimes you need end caps where the pod has been taken apart. However, this is completely, I guess, unrelated to SlabTank. SlabTank is a single molded product, so it's molded end to end, side to side as one product. There's no caps, there's no modularity as such for this tank. It is a one-piece molded unit, so no fear there. There'll be no clips or moving parts with the SlabTank.
Awesome. Great. Thanks, Peter.
I appreciate it. Thanks for the questions. And thank you all for joining today. It's been an awesome privilege sharing it with you. So yeah, as we wrap up, we have got all those resources. We will be sending through a recording and some resources for you as well. So thanks very much for joining. Michael also has got another webinar next month, which you guys will want to hear about as well. So if there's no other questions, I'll let Michael let you know about that.
Yeah, thanks, Peter. I just had one more comment as well on the last question about somebody putting a bolt through the top of the slab tank. As a designer, I wouldn't be too worried about that because that will be covered in concrete and it's never going to have any hydrostatic pressure on it because the tanks have an outlet at that level. So even anytime the tank fills up to the top, it will drain. It can't fill higher than that. So it's not ideal, but it's probably not going to be a showstopper. So
Yep.
Thanks everyone for joining. As Peter mentioned, you will get a follow-up email with the resources. The recording will be made available. And we have a number of extra webinars coming up in the coming months, and we'll keep you posted as to those. You can check out all the recordings of the previous ones at dynamiccpd.com and also register for the upcoming webinars. So thanks everyone. We'll call it a day and appreciate your time.
Champion. Thank you.